So, welcome back to another quick session where we're going to be learning about how to decode an IP frame and a TCP segment. So, when it comes to an IP frame, let's revise what we have learned before. So, there's something called version, there's something called internet header length, then there's something called terms of service, and then there is length. Then there's something called an identification number, flags, and fragment offset. Then below this, there's something called time to live (TTL), protocol number, and header checksum. I remembered up to here, but I had forgotten, so I'm gonna quickly check. And under this, there's the source IP, then there's the destination IP. Below that, there's gonna be something called options, and then there's something called padding, and finally we will have our payload. So for me, they're gonna allow a reference sheet, so I probably will be taking this in the reference sheet, but I'm trying to memorize this because it's saves up some space for my reference sheet. So I hope you work accordingly. So when it comes to the version, it uses 4 bits. The header length, it also uses 4 bits. Terms of service uses 8 bits. Length is 16 bits. ID number was also 16 bits. Flags is 3 bits and fragment offset is 13 bits. Time to live is 8 bits. Protocol number is also 8 bits. Header checksum is 16 bits. An IP address is 32 bits. Destination IP, again another IP address, it is also 32 bits. We do not consider options padding yet. So let's say we have something like this. Okay, so this is a set of numbers, right? So each of these are in hexadecimal, right? Hexadecimal, which is considering 4 bits. So each of these is a hexa pair. This is a hexa pair, this hexa pair, so on and so forth, right? So since all of these are bytes, right? Each of this is a byte, right? Each of these is 1 byte. 1 byte has 8 bits, meaning 2 hexa, so on and so forth. Okay, so I am gonna delete this, paste myself another version. Okay, so let us look into this. So first we have version, which is 4. So if we take 4 and we write it in binary, we'll get 0, 1, 0, 0. Now I want you to be very clear here. When it comes to binary, we always start with 2 to the power 0, and pardon me, so we start with 2 to the power 0, 2 to the power 1, meaning we start with 1, 2, 4, and so on and so forth. You should not mix that one up. Okay, so anyways, here we have 4, which is written as 100, right? So essentially what this is saying it's IP version 4, right? I think we learned it. So IPv6 is 101. Pardon me, not 101, 110, right? It's essentially just saying that IP version. But for here we have 4, which is IPv4. Next we have 5, which says the header length, right? So you can, if you want, you can write it down. So it's 101, right? Essentially it's 5. That 5 is what will show us how many how the length of the header, right? So 5 into 4, remember we should always multiply by 4, is going to give us 20. This is the header length and this is the minimum header length, meaning since minimum is 20, there is no extra here, right? So there's nothing under options or anything, right? And you should also know maximum is 60, right? So yeah, so this is 20 bytes. I hope you know that. Next we have terms of service, that is 8 bits. So 8 bits means this part, right? This entire part. Now 4 means only one number is reserved for version and only one number is reserved for IHL, right? Okay. So you may be wondering, hey, that I can only write 0 to 9 here, right? How can I get one ones? Well, remember these numbers are on hexadecimal. So we have 0 to 9 and then we have A to F, where F is equal to 15. So as you know, if the maximum is 60, divide 60 by 4, you get 15, right? And 15 is what F is, which is 111. Just extra knowledge. So anyways, let's focus on this, right? So next we have 00. This is 8 bits terms of service. So if we write that in in binary, we're going to get something like this, right? So I think you may have all known we wrote something like this. ABC is for priority or precedence. Precedence. Then we have D, E, F, and G, H. D is for delay. E is for if it's high throughput. F is if it's high reliability, and GH is reserved, or we learned it as unknown, right? So continuing with this, since none of this is 0, we don't have to consider any of this, right? So moving on, length is 16 bits, meaning we have to consider this entire bit 0028. So 0028, this is in hexadecimal format, right? We have to convert it into decimal format to get length. So there are two ways to do this. One, you can write it as in its binary format. 2 is 0010 and 8 is 1000. So as you can see, none of these values matter. So here we're going to get 2 to the power 3, 2 to the power 4, and 2 to the power 5. So 2 to the power 5, so 1, 2, 4, 8, 16, 32. 32 plus 8 is going to give us 40 bytes, right? But so this is one way of doing it. Another way of doing it is like this. It's called the, so you may have seen something like this. So this is basically going to convert this into decimal format, where essentially we do something like this. We take each of these numbers, so and we multiply them by the base. So as you can see here, you're going to get 8 times 1 and 2 times 16. So that is 32 plus 8. So right now this is, as you already can see, this is less work than this. Let's say you have something like 1, 2, 3, 4. Well, instead of like converting all of this into binary, something like this, and then multiplying by 2s, this is way more easier, right? So let's move on now. So as you can tell right now, the header, the total length is 40. So the header length is 20. So now you know the payload length is also 20 bytes, right? Right. Now let's move on. ID number is again another 16 bits. So we do not need that to convert the ID number usually, because ID number is usually used in binary. And right now we have something like 3A7F. We don't convert this to binary. We can directly convert this to decimal if you want, because it's an identification number and it's usually staying in hexadecimal, but it's best that you know how to convert it. So as you all know, A is 10, F is 15, right? So we can do 15 times 1, 7 times 16, 10 times 16 squared, and 3 times 16 cubed. So I believe if you do the calculation here, I have done it previously, so let me bring up my notes. Right, so 3A7F is gonna lead us to uh, so it's 14,975. That is the identification number for each of these packets. So now we have 0000. It's best we write this down in binary. Right now there is not much of a use here, but as you already saw, we have reserved 3 for flags and the rest for the fragment offset. So here the fragment offset is equal to 0, right? Here we have 0 0. So first one is always going to be a reserved bit. That's going to be 0. Second one is going to be a do not fragment bit, fragment flag. That's going to be 0. And then we have more fragment flag. It is also 0 in this case here, right? But it is subject to change. So now we have taken care of this. So let's move on to the next 8 bits. This 80 is going to show us the TTL, time to live. So it's 80 and then we have 11. So 80, time to live. So if we convert this into binary, we get 1000 and we get 0. So this is 128, right? So again, you can also convert this using base decimal values. So it's gonna get 8 times 16, which I believe is equal to 128. I'm not sure, but I think so. So this is how many more routers it can go through. Next we have protocol, which is 11. So again, this is hexadecimal, so we can convert it to decimal by going 1 times 1 plus 1 times 16, which is 17. So you should know what some of these protocols mean. So 17 is UDP. There's some others, so I believe you find some of these, you find for TCP, UDP, ICMP, ARP, so on and so forth, and you mark them in your reference sheet. So we have done 11. Next we have finally we have header checksum, which is B892. So header checksum usually is always in uh, hexadecimal, so it's unless they ask to change it, do not change it, keep it as it is. Finally we have a source IP address and destination IP address. So when it comes to source IP address, it's AC100005, AC100005. So I want you to know something. Do not convert this completely. Each of these is for each octet, right? So A is 10, C is 12. So if you convert each of these to, this is gonna be 16 plus, and this is gonna be, I believe, 16 plus 2. So I think it is 32 plus 2, 34. Oh no, sorry, my bad, my bad. So it is 10 times 16 and 12 times 1. See, I made the same mistake, so don't do it like that. So this is how you should treat each value. So this is going to be 160 plus 12, 172. That is a singular octet. Here you will have again 10. It's going to be 1 and 0. So 16 times 1. So here it's going to be 16. Here 0, 0. So you can put a 0 here. And I believe this is a 5. So again you can go 0, 5, 16 times 1. So this is, don't worry about that. Dot 5. This is the source IP address, and I believe the destination IP address is AC10001. AC10001. So we know this is 172, we know that this is 16, we know that this is 0, and I believe 1 will obviously convert to 1. So this is the destination source IP address. Destination IP address, sorry, destination IP address, right? So let's say that for some weird reason or for any reason this is greater than 5, so it could be a 6, 7 or 8, meaning it can be either 24, it can be a 28, or it can be 32, it can be any value, it can be even be 60. That means there are extra optional uh, stuff in here, right? Optional header stuff in here that will be written over here, that will be included in here itself. So if you see more numbers than this, right, then you should know, okay, these are some of the stuff that are under options. And I think that is IP frame format. So let's move on to TCP segment. So now we will have the source port, which is 16 bits. Then we will have the destination port, which is another 16 bits. And then you will have the sequence number, which is 32 bits. Then you will have acknowledgement number, which is also another 32 bits, right? So then you're gonna have the header length, which is 4 bits. So with 4 bits you can represent values from 0 to 15, right? So maximum is 0. So here, as you all know, the minimum value will always be how much? 4, right? Because you had to get 20 minimum header length. Then you have header length, you have reserved bits. What's it reserved for? Nobody knows. As in, it's not nobody knows, it's like for future innovation, so on and so forth. 6 bits is reserved. Then you have the flags, you have the urgent flag, you have the acknowledgement flag, you have the push flag, you have the reset flag, you have the synchronization flag, and then finally you have the finish flag or termination flag. This is again 6 bits, right? Each of them 1 bit. Then you have window size. So 6, 6, 6 and 4, that's gonna make 10, 16. So here window size is gonna be 10 bits. Is it 10? Oh no, it's gonna be 16, because it has to be equal to the number. Maximum is 32, right? The length is like 32, right? It comes underneath all of this. So 16. Then we have checksum, which is also 16 bits. And finally we have the urgent pointer, which is also 16 bits. Finally you have options and padding, and below that you will have payload, right? So now let us go through some for TCP segment. So here they will give you something like this, and what they should mention along with that is payload amount. So here for my question they have given me 160 bytes, right? Okay, so again they're saying 16 bits is for source, so that means this is for source, this is for destination port. Then they're saying 32, right? So 32 means 4, 8, 16, 32, and 32 for sequence number. Then you have 32 for acknowledgement number. Then we'll move on. Okay, so first off, when we have 1455, you have 1455. So you must convert this into hexadecimal. You have conversion. Do conversion here. So essentially, it's just multiplying and figuring stuff out. Again, you're gonna get 16 and 1 here. You're gonna get the specific numbers, uh, source port number and destination port number. It's best that you know some of the reserve port numbers, some of the well-known ports and all that stuff, so you can clarify. It's best you write it down in your um, answer sheet. So here you want to get a 4096 times 1. So what you're gonna get is, I believe I have already done the addition, correct me if I'm wrong. So this is 5205. This is gonna give me 16 plus 7. It's gonna give me I think it's gonna give me 23. The source what is this? Sorry, that's the sequence number. The sequence number is gonna be 65. Acknowledgement number is gonna be 54, and then finally we need to find the header and header length reserved and all that stuff. So 4 bits is reserved for header length. So first of all, let's go write it down. B030, 4 bits. So this bit is reserved for header length, right? Not reserved. It's like it is meant for header length. So B is, I believe, 11. 11, when you write in binary, you can write it like oh yeah, B is 11, so it's 0011, right? This is binary. So if you convert this 11, and no need to convert it, actually you don't need to convert, you can just simply multiply it by 4 to get 44 bytes. So this is how the header length of the segment, by the way, this is not a frame, this is a segment, remember that. Then we have 0, so it's 0 0 0 0 3 0 0 1 1, and we have 0 again, 0 0 0 0. Now remember they're saying 6 bits are reserved, so 1 2 3 4 5 6 has to be reserved, right? Then they're gonna say something like this: 6 bits. How many bits here? 1 2 3 4 5 6, and out of these 6, only the first 2 are 1, meaning the urgent flag and the acknowledgement flag, only those are active, others all are basically off, right? Okay, so now you have another 16 bits. So you have 0 to 0 0. So this is 2 times 16 squared, which is 2 times 256. So you're gonna get 512. 2 times 512. So what is 512? 512 is the window size, right? So it's actually 512 bytes. That's the window size. So now we have dealt with that. Finally, we have to deal with checksum, which is 16 bits, and urgent pointer. So checksum is gonna be 0, as you can see here, and urgent pointer is 0060. You have to take this as an entire clump. So remember back then when we did the IP addresses. So A, B, C, D means each of these are its separate thing, right? It's not a singular clump. This is a singular clump which you have to take, right? All of these, you're clumping them together. They are not two different digits. You're clumping them all together. Here, you can't clump them together. Do you understand? You can't clump them together. Here, you have to clump them together. Here and here. Finally, when you come here, you're going to get 6 times 16, which is going to give you 96, right? So now, they will give you a question, something like, since you know everything, draw the urgent pointer with the control field and everything, with the sequence number. So what's the sequence number? As you know, sequence number was 65. So we are starting off with the 65th sequence number, right? Payload is 160. So if it's 160, what will happen is it will say the acknowledgement will be sent. So 160 plus, if you add a 160 here, 5 2 to 225, right? So 224, meaning because 65 is also one of the 160, right? So it will send the 224 and it will send the acknowledgement after this saying I am expecting the 255th data from you, right? So we do not care about the header size here, we only care about the payload size here. When it comes to sequence numbers, we only care about the data. Okay, right. So now we have 65, we have a 160 byte size payload ending at 224, right? The urgent pointer, how much did we say, was 96, meaning the urgent pointer says up to 96, right? So that says up to 96, this is considered as urgent. This one can be processed normally, right? And the ACK that we ACK value, acknowledgement sequence number value, that is equal to 54. That is not relevant to this. That is saying, now essentially what's happening is there's a piggybacking happening here, right? So it's sending the data plus acknowledgement for previous received data, saying, hey, I received up to 53, send me the 54th sequence, the 54th, right? So this is all there is to learn about TCP segment, how to read this thing. It's best that you mark this one for both IP frame and as well as TCP segment. And I hope you understood, and good luck. Have a great day.